So now that we're done with the math, alhamdulillah, it was, we really took long days of math, but I hope that you got the gist of it. Now we're on the science questions. يعني we're basically talking about basic science principles and like involving physics, chemistry, and biology. I hope that you like science, I guess. Do you like science?
Only biology, to be honest.
Yeah, I agree with you. Biology is really interesting.
Yeah.
Okay. So yeah, we're gonna see here basic principles. We're not gonna do we're not gonna go much in deep. So let's see here the first question. Benefits of having frictional force in nature. So do you know what frictional force is?
Yeah.
Yeah, so what is it?
Is it when an object like slides off another object? Like there's something stopping it from going further?
Yeah, exactly. So in Arabic it's called قوة الاحتكاك. ممتاز. So
When two
yes,
objects rub against each other, صح?
yes, exactly. So any two objects when or basically any object that moves, it's gonna have a frictional force against it. So if there is a box, yeah. Okay, if there is a box that is moving this way, there's always going to be a friction force going the opposite way. Okay? In each object in life. If it's like in touch with anything, even the ones that fall, it's in a friction with the air particles. So there is also friction with air. Okay? So the question here is asking about the benefits of the friction force. So what do you think the answer is? Yes, Abdullah?
So friction reduces the speed, so wouldn't it be A?
It is going to be A, Mumtaz. So the answer here is reduces speed and makes objects stop. So that's its main purpose, to stop objects. Mumtaz. So here also it helps to move and walk. You can say that it's practically also doing the same, but we're talking about the main benefit of frictional force. Like any, it helps us move, as in if you walk, for example, on ice and there is little friction force there, it's gonna be hard to move. You're gonna always slide and fall. So if there's no frictional force, you're not gonna be able to walk correctly. But it can apply, but the most correct answer is A. That we're gonna take a talk. We're talking about the main idea here. Okay. Question 2. Herbivores are غير عبد الله. Anyone knows what herbivores are for?
It's A.
It is A. ممتاز Maria. Herbivores are plant eaters. Excellent. So herbivores are the ones that only eat plants. And what are the animals that only eat meat called? Anyone, open your mic.
Carnivore.
Carnivore, exactly. Carnivore only eats meat. And the name of the animals that eat both meat and plants.
Omnivore.
Omnivore, exactly, ممتاز. So it is omnivores. Okay, so they eat both. So actually, us as human, we are omnivores because we're considered under the umbrella of animals. So yeah, that's a fact to know. Okay. So herbivores eat plants, carnivores eat meat, and omnivores eat both. ممتاز. يلا, question 3. Anyone can read question 3? Yes, Abdullah.
Is it going to be math?
Yeah, so can you read the question first?
Which of the following part is not affected by a change in state from solid to liquid?
Yeah, so you say?
Mass, because like size is going to change because we're changing to a completely different state, so it's obviously going to be different.
Yeah,
And the shape,
yeah.
and the shape, since we're also again changing the state, it's going to change. But I'm not sure what coherence means exactly.
Okay. So Mumtaz, mass is the right answer. And now I'm going to explain how. Okay, so here they're basically talking about the states of matter. We know that they are what are the states of matter?
Solid, liquid, gas.
Yes, solid, liquid, gas, and they're also contemplating about plasma. But here we're gonna see only the three, the solid, liquid, and gas, and we're talking about solid to liquid. So you can put an example for your mind in your mind, which is ice to water, solid to liquid. So coherence means how close the atoms or the particles are to each other. So if I have an ice cube, okay, in this ice cube, I'm going to have the atoms or the water particles really close to each other so that they create this solid structure. Okay, so it's not going to be real solid if it was not that close. But in water, if I have a bowl of water, for example, like this, it's not going to be that close. It's going to be a bit more scattered. Okay, so that's why it's more flowy. If it was really, really close, like solids, it's not gonna flow. You see that ice do not flow. Okay, so that's what coherence is, how close the atoms are for each other. And lastly, if I'm talking about gas is just really, really far away particles. Okay, that's why it cannot really be in a form or a shape. Here, at least it's in a shape. It can be contained in a shape. But if the particles are so far away from each other, they cannot even be in a shape. Okay, so that's coherence. So we see that coherence differs from a state of matter to another. Each one is different. The most coherent one is solid, the least one is gas. As for size, you see that when you, for example, put a bottle of water inside the freezer and suddenly it bursts out, or when you take a freezed one and you try to open it and the water starts to leak. I don't know if you experienced this before. Yeah, so that's because when water became solid, its size differed. It became different, so that's why it's occupying more space. Its size is bigger. So size also differ in when the matter of the when the state of matter differs. Also shape, we know that we can form shapes like ice cubes, ice balls, but we cannot make that for water. We cannot form a cube of water, except if it was contained inside a cube. Otherwise, it's going to be just in a different shape. Okay, so coherence, size, and shape all differ when the state change from solid to liquid, except for mass. If you put it on a scale, if you put the ice on scale, it's not going to change even if it melts and becomes water. It's only going to change if you take out some water or you add some water more. Okay, so that's how mass changes. But only the change of mass of the state, it's not going to change it. Okay. So is that clear, guys?
Yes.
Okay. Excellent. Yalla, let's see the next question here. Yes, Haida.
Okay, so the weight of the body on the moon is less than that on Earth because the gravity of the moon is less than that of the Earth. Because weight is just mass affected by gravity.
Exactly. Mumtaz. Mumtaz. And your reasoning is also right. So here, when the body is in the moon, you can see astronauts like jumping in the moon not because their mass is less, not because they lost fat, but just because the effective gravity is less on moon than on the Earth. Okay. So is that clear, guys?
Yes.
Okay. Mumtaz. Yalla. Question 5. Fusion. What is fusion? What do you think fusion is? So actually it is, yes, Fatima?
Is it like and for example a bomb and when something explodes?
Yeah, no, that's a different thing. Fusion is like, have you seen videos of iron melting in really hot atmosphere, like under fire,
Yeah.
and it starts melting? Yo, so that's basically the fusion. So it is the transformation from solid into a liquid. Okay? So in Arabic it's called al-insihar. Okay?
Miss, how do you know it's this fusion, not that fusion?
So the context of the question. You see, they're asking here, the context is, or the topic of this question is the states of matter. So you know that the fusion here, it's meant to a process of change of matter. Okay, so you think on that way. Okay, so basically here we have the types of processes in the changing of states of matter. We saw here the fusion or melting from solid to liquid, and an opposite, it's freezing from liquid to solid. We have from liquid to gas, evaporation, and from gas to liquid, condensation. You know, as in when like cold air condensates on when air condensates on cold stuff. Okay, and forms the droplets. Okay, and we have sometimes the solid goes directly into gas, which is called sublimation, and gas goes directly into solid, which is deposition. Okay, so this one you have to put it in mind. So they might ask questions about the states of matter.
Miss, I have a question about freezing.
Yes, Haida.
Why does the liquid, like when it freezes, like normal liquid like water, like when it freezes, it's liquid until it like moves or something and then it turns into ice? Like why can't it like just turn thicker and thicker until it becomes ice.
You mean that
like getting closer.
It stays like the same in the same viscosity. You mean like it doesn't get thicker like
No, I
from
mean like
water
why
to
can't
honey
it like yeah, like why can't it just smoothly become like the particles get closer and closer?
Yeah, so that depends يعني on how the atoms are يعني getting close to each other. This happens on other matters like honey. When it gets like getting into solid form, it's going to be as smooth as you imagine, I think. But in water, it's not actually just getting closer, it's crystallizing. It's forming crystals. So crystals are more harder than others, like harder than when we freeze honey. Okay, so in honey, it will be smoother. In water, it's going to be crystallized. So that's more in depth about like how is the connection between the particles inside the matter. It depends. Okay. Okay, let's see the next question now. Question 6. Anyone can read the question? Yes, Fatima.
A man passed by a compass and its pointer moved. The reason for this is that the man...
Okay, so do you have a guess? Yeah?
Is the man يعني holding the compass or the compass is far
No.
away?
So the compass, the compass is like what's used for directions.
Yeah.
Okay. So the man, this is the man, he was just walking by. Okay. He didn't touch it. He didn't go near it. He just walked by it.
Maybe B.
So holds a piece of magnet. Yes,
Yeah.
Mumtaz. So B is the right answer here. Why do you think the answer is B?
Maybe because magnet moves the pointer.
Yeah, exactly. So actually, the pointer inside the compass, or the needle inside the compass, this one, okay, is actually a small magnet, okay? And it reacts to what? It reacts to the poles of the Earth. So our Earth is actually a big magnet that has a south pole and a north pole. So this this needle is acting upon this one. So that's why it's always going to north. The needle is always directing us to the north. Okay. So here, when another piece of magnet passes by it, it's closer, it has more of force affecting this needle, it's going to move it with it. Okay? So is that clear?
Yes.
Okay, excellent. Okay, so let's see question 7 now. Yes, Abdullah, do you want to do question 7?
Okay, sure. If a pulley 1 moves on clockwise, pulley 2 will rotate. Real 1 has a diameter of real 2.
So first, let's see. Will it go clockwise or counterclockwise? This one.
So since the first one is rotating to the like from right to left, the rubber, I don't know what it is, like also make it. It's gonna make it move clockwise because.
Yeah. So yes, exactly. So it's gonna move clockwise.
Clockwise.
Yeah. So it's going to move clockwise. So we can remove C and D because they're saying counterclockwise. So we have the rest here. Is it 1 cycle or 3 cycles? What
I
do you
think it's
think?
gonna be 3 cycles because like it's bigger than the other one, so like it's gonna make him move more because it's like a bit heavier in a way.
Yeah, exactly. ممتاز. So here it's going to be 3 cycles with يعني clockwise. So basically it's because of the diameter, and it's bigger in the real one and it's smaller in real two. So if you imagine like going in a roundabout in the road, if you go in the roundabout and it's really big, like this one in Sehat, I don't know if you know it. It's a really, really big roundabout that you really need a long time to go from one point to another. So the larger the diameter, the longer it takes to take one full circle. So since this one is smaller, it's obviously going to have much less time to complete one circle. So they're saying that for each one circle or one cycle of this big one, the small one would complete 3 full circles. Okay. And how do we know it? By math or by like mathematically? You just take the ratio between diameter 1 and diameter 2. So it's 3 over 1. So it's going to be 3. Okay, so is that clear?
Yes.
Okay.
Wait, can you explain again
Which
only
one?
the 3 parts?
This one?
Yeah.
Yeah, so you basically take the ratio between them. So for example, if this one was actually 6 and this one was 2, what am I going to do to find how many circles or how many cycles would this make? I'm just taking the diameter of this one, of the big one, which is 6, over the diameter of the small one, which is 2. So I'm going to have also the same answer, which is 3. You take the ratio and you find the number. For each one cycle here, the small one would have 3 cycles.
Okay, thank you.
Okay, you're welcome. Okay, so in question 8, we basically answered the question above. If pulley 1 rotates clockwise, the pulley 2 will rotate also clockwise since it is connected with this rope thing, okay? So since it is connected that way, it's going to go in the same direction. But there is another way of connecting it, like this way. Wait. This way. Okay, in this case, when this big one goes clockwise, actually the other one will go counterclockwise. Okay. So in this case, if it's not crossing, it's going in the same direction. If it's crossing, it's going opposites. Okay, so here, the answer here would be clockwise because it's not crossing. Okay. Yalla, the last question and we're done for the day. So who can read the question? Yes, Fatima.
Which of the following conditions can an equal mass of the same material be drawn on a smooth surface with the least force?
Yeah, so one. Yeah, so it is. What do you think it's gonna
Miss, I
be?
don't understand the question.
You don't understand the question?
No.
Okay, so يعني they're asking basically if I have a box and I am dragging it, which one would be the easiest way? So that I'm not gonna use much force.
A.
It's not gonna be A. Why? Because here I am trying to move it in that direction. when I pull it up like this, I am exerting force in this direction and in this direction also. So this one would not be my full potential. This here, it's not my full potential. So it's not really exerting force as much as I want. I'm gonna need much less here to force for this one to be enough. And the same here as C, for example. Of course, this one is going to pull it up more than it's pulling it to the right. And this one here, D, it's going to pull downward also, as well as pulling it to the right. So I want my full potential to go in the direction that I'm moving. Okay? So here, answer would be B, because I'm directly going, all my force is in the same direction. It's not going any other way, up or down. Okay, is it clear?
No.
It's not clear yet?
No.
Okay, so here, you try to imagine and pulling the box upward. When you're pulling it upward, you need more force to moving it to the right. What you want is moving it to this direction. It's better. يعني let me let's put it by numbers. Okay? I'm here doing the power of 6 Newton, for example. I'm doing it for all of them. This is 6 Newton, this is 6 Newton. So Newton is the unit for power. So here, 6 Newton is going to the right. Right?
Yeah.
Yeah. But in this case, 6 Newton will be divided into the right and above because it has some effect upward. Right?
Yeah.
It has some effect upward. So here it can be 3 Newton only going to the right and 3 Newton affecting has an effect going upward. So if I compare between the 3 Newton here, 6 Newton here, which would be or having more effect?
The 6 Newton.
The 6 Newton, yes. If I want this to be the same as this one, I'm going to need much more power, or يعني original power. This 6 Newton should be more so that I can have an effect.
Okay.
Yeah. Okay. So is it clear, guys? All of you, is it clear?
Yes.
Okay.